This is the second video on the nomenclature of alkanes and cycloalkanes. In this case, we're going to look at specific examples. If you want a more detailed explanation of the rules, check out the other video. Just a brief summary of how we name these things. First, we have to identify the parent chain, right? That's the longest continuous chain. We then need to identify and name each of the substituents. Then we need to decide how we're going to number the parent chain and assign a number to each one of the substituents. And then finally, we list each of the numbered substituents before the parent name in alphabetical order. All right, so the first thing we have to do is decide what is our parent chain. So we want to know what is the longest continuous chain, right? And organic professors like to try to trip students up with these types of problems, right? And so the obvious chain would be 1, 2, 3, 4, 5, 6. But I think we can make it longer. If we go 1, 2, 3, 4, 5, 6, 7, 8, I think that's the longest chain that we can do. And so that's going to be our chain. And so our parent is going to be 8 gives us octane. And then the substituents are here, here, and here. And those are all methyl groups. And there's 3 of them. So our name is going to be trimethyl, but we have to figure out how we're going to number it, right? And so I could either start from here, and I would have 1, 2, 3, or I could start from here, and the first one would be 1, 2, 3. All right, so whichever end I start from, the first substituent is going to be 3, so then I want the second substituent to be as low as possible. If I start from here, 1, 2, 3, 4, 5, that's not as good as 1, 2, 3, 4. So this is going to be my 1, 2, 3, 4, 5, 6, 7, 8. And so the name of my compound is going to be 3,4,6 trimethyl octane. All right, and normally we'd want to join those two names, but I gave myself too much room, so I might rewrite it, but I'm not going to take the time to do that. 3,4,6 trimethyl octane. Okay, our next example, again, we want to try to find the longest chain. And so I think I can go 1, 2, 3, 4, 5, 6, 7. That's the same as 1, 2, 3, 4, 5, 6, 7. Or I could go 1, 2, 3, 4, 5, 6, 7. So the first two I think are basically equivalent, but the way to differentiate between whether to go like that or like that, they both give me 7, but I want to have as many substituents as possible. So the one that will give me the most substituents is the way to go. If I go this way, then I only have one substituent. I have an isopropyl. If I go this way, then I have 2 substituents, a methyl and an ethyl. And so I always want to have more substituents because that is going to make them less complicated and easier to name. So my base name is going to be heptane. And then I have a methyl and an ethyl. And I want the first substituent to be as low as possible. Or if I started from this end, it'd be 1, 2, 3, 4, 5. If I start from this end, it'll be 1, 2. So that's what I want to do. And so I have a 2 methyl and a 3 ethyl. And so when I put them in, I'll put them in alphabetical order. So the E in the ethyl comes first. So I have 3 ethyl, 2 methyl heptane. Okay, now we have a cyclic compound, and the cyclic is my longest. I have 1, 2, 3, 4, 5, 6, whereas here the most I can get is 1, 2, 3 in the straight chain. So my base is going to be the cyclic compound here. And so 6 is hexane. When it's cyclic, we give it the prefix cyclo. So my parent is going to be cyclohexane. And then I have 2 substituents, I have an isopropyl, and a methyl. Now, when I number this, I want the numbers to be as low as possible, but just based on that, it doesn't matter how I go, right? It could be 1, 2, 3, or 1, 2, 3. And so then the tiebreaker is going to be, I want it to be, the first one alphabetically should get the lowest number. So that means I want to go 1, 2, 3. So the isopropyl gets a lower number than the methyl. And so the name of our compound is going to be 1 isopropyl, 3 methyl cyclohexane. Okay, in this example, I wanted to do one to demonstrate that the cyclic, the ring structure, isn't necessarily always the parent, right? In this case, I have 1, 2, 3, 4, 5, 6 in my straight chain. I have 1, 2, 3, 4 in my cyclic, and so this is going to be my my parent, and this is going to be a substituent. And so we said it was 1, 2, 3, 4, 5, 6. So my parent is going to be hexane. And then, right, if I just had a four-membered ring, it would be cyclobutane. When it's a substituent, instead of being cyclobutane, it's cyclobutyl. So I got to tell you where it is, right? It's 1, 2, 3. So it's 3 cyclobutyl hexane. Oops. 3 cyclobutyl hexane. All right, so we want to find the longest chain again. So I think I have a 1, 2, 3, 4, 5, 6. And I have a 1, 2, 3, 4, 5, 6. Or I could go off on either of those sides. I still get a 6. So again, my rule is going to be I want the one that has the most substituents to be the parent. Right? So if I go 1, 2, 3, 4, 5, 6, it only has one substituent. It has the tert butyl. Whereas if I go 1, 2, 3, 4, 5, 6, then I have 1, 2, 3 substituents. So that's the way I want to go. So that's going to be my parent. So I have hexane again. All right, and then I have 3 substituents. I have an ethyl. Try that again. A methyl. And the methyl. I think clearly I want to start numbering from this end. And so I have a 2-methyl and a 2-methyl and a 1, 2, 3 ethyl. Now, because I have the 2 methyls, that's going to be 2, 2 dimethyl. But when I put them in alphabetical order now, I don't include the dis and the tris. So even though it's dimethyl, I still use the M for putting them in alphabetical order. So it's going to be 3 ethyl, 2, 2 dimethyl hexane. Okay, I wanted to do this one to do an example when we have one of these complex branches. Right, so in this case, my longest chain, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can get 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So the best I can do for my parent chain is 10. And so that's going to be my parent, and then this whole thing is going to be the substituent. So the parent, 10, is going to give me decane. And then I think there are a couple of different ways that people name these complex branch substituents. I'm going to follow the way that our book does. And so the book says, all right, the carbon that is attaching the branch to the chain is always going to be 1, and then making that 1, I want to make it as long as possible. And so we're going to have 1, 2, 3. So this is going to be a propyl group. And then that group has 2 substituents. It's got 2 methyls. So it's going to be 1, 2 dimethyl propyl. So that whole thing is the name of the group. Now, when I put that with my parent, it's going to be kind of confusing. Like, what, do the numbers refer to? And so what we usually do with these complex chains is we put the whole thing in parentheses, because I've also got to tell you where this is coming off, right? So it's coming off of 1, 2, 3, 4, 5 in the parent. So it's going to be 5, and then in parentheses, the name of the substituent, the 1, 2 dimethyl propyl, and then the parent is decane. So it's going to be 5, 2 dimethyl propyl decane. Okay, so this one looks a little bit ugly, but I think if we follow our rules and take it systematically, we can get it down. So we got to find our longest chain. I think 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So I think 8 is the best we can do. So that gives us octane. And then I have a couple substituents. So this will be cyclopentyl. We have a methyl. And then this is our tert-butyl. I wanted to specifically do an example with tert-butyl because it's a little bit weird. If you notice, when I wrote isopropyl, I wrote it as all one word. And when I wrote tert-butyl, I wrote it with a dash. And the other weird thing about it is when I alphabetize isopropyl, I use the I. For whatever reason, when we alphabetize tert-butyl, we use the B. So that's sort of a difference between the isopropyl and the tert-butyl. I think numbering-wise, right, if I go this way, it'll be 1, 2, 3. If I go this way, it'll be 1, 2. So I want to do 1, 2, 3, 4, 5, 6, 7, 8. So for the tert-butyl, because I'm going to use the B, it'll come first. So I have 4 tert-butyl. Then C will come next, so I have 2 cyclopentyl, and then I have 6 methyl octane. Okay, our last example. So I think my longest parent is going to be the cyclohexane. All right, and then I've got a number of substituents. I've got a methyl, an ethyl, a propyl, a methyl, and a methyl. Now, when I'm numbering this, I think my options to get the lowest numbers are to go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. And so then my tiebreaker, because going either way is going to give me the same numbers, is alphabetically, right? If I go here, I've got methyl, methyl. Here I'd have methyl, ethyl, right? So the tiebreaker is ethyl comes alphabetically before methyl. And so my numbering is going to be 1, 2, 3, 4, 5. So alphabetically, ethyl should come first. So I'm going to write them up here because I'm going to run out of room going left to right. So my first substituent is 2 ethyl. And then I'm going to have a trimethyl, but we don't include the tri and alphabetization. So when I'm comparing trimethyl versus propyl, I want the trimethyl to come next. So I'm going to have 1,4,5 trimethyl. So we'll do 1,4,5 trimethyl. And then I'm out of room, so we'll do it down here. Then it'll be 3 propyl, cyclohexane. So 2-ethyl, 1,4,5 trimethyl, 3 propyl, cyclohexane.